Okay, great. So thank you for inviting me to speak at this event. I'm not an academic, but I have views on what we need from academia in this time of emergency, and in terms of what that means for the graduates who come to the workplace. I work at both the Institution of Structural Engineers and at Arup, which means that I am going to talk to you both about what the institution can do for you as academics, and I'm not sure of everyone's background who's on the call. And then I'm also going to talk to you a bit about, like I say, my views on what I believe the industry is going to need from graduates who enter into it, and maybe how that differs from what they currently have when they enter into that first job at the end of 4 years of hard study. So my introduction to sustainable design probably happened about 8 years after I graduated, and it was on this project that I went to work on in Rwanda, which is covered in earth walls, timber roofs, stone foundations. It's naturally ventilated, it's shaded from equatorial sun, and the carbon footprint of the whole project is something like 175 kilograms of carbon per square meter, which is way below what people would term business as usual. And then the landscape architects convince the client to let them cover the rest of the site in enough trees to offset that carbon. And this project will be carbon neutral long before we hit 2050. And neutral was an interesting term to be using in terms of carbon whilst working on this project, because the architects who designed this campus that I worked on, Mass Design Group, have one of these views that they hold is that architecture is never neutral, and it either hurts or it heals. And I've heard architects from the firm apply that to sustainability in this architecture. It's never going to have neutral impacts on the planet. It's either going to be harmful or it's going to be healing. And I think that they would agree with me that in terms of what you teach your students, if you're not teaching them to be climate activists in their work, then you're effectively telling them that the opposite is okay, and that it's okay for them to continue practicing how the rest of us has practiced for so long in harming this planet. So I thought it'd be interesting to try and work out in the mindset of a student what sustainable design looks like. And I went onto Google and typed in sustainable architecture, and this came up, and this is clearly bonkers and couldn't be further from the truth. If you do a back of envelope sum, you can pretty quickly work out that for every 1 square meter of building that you build, you need to plant about 10 square meters of forest if you want to offset that carbon within, say, 50 years. So the idea that all we need to do is cover our skyscrapers in a bit of bush and that's going to solve all of our problems couldn't be further from the truth. And it really frustrates me that this is the sort of starting point that some people might get into thinking about what sustainable design really means, and it's just miles away from where we need it to be. I then thought I'd go on further, so I asked one of our graduates who we hired only a couple of years ago, one of the best people we took in at Arup that year, and I said to her, did you get asked to look at sustainability in your final year projects? And she said, yeah, of course we did. So I asked her if she could send me something about it. This is a bit of one of her posters from her final year design project. And under sustainability, it talks about geothermal heat exchange, hermetically sealed envelope to reduce energy demand, and 100 bike spaces. That's not sustainability. That's words being reprinted on a final year presentation. And there's this complete detachment, I think, between what we get taught at university, and I was only there 10 years ago, and this sort of resonates with me, the difference between what we need to be doing in order to tackle the climate and biodiversity emergency and what we're actually teaching students that sustainability means. They're worlds apart, absolutely worlds apart, and that needs to change. So my call to you as academics and as lecturers and as people who are going to influence these young students in their views about what they think their job is going to be, is to help them understand their ethical responsibility. So you need to help them understand this 39% thing that somehow the legend has got messed up on the right, but we all know 39% of all energy-related carbon emissions are due to the buildings and construction industry. Hopefully these next ones will work a bit better than that. We need to help them understand that whilst for years and years operational carbon has been coming down, embodied carbon has about stayed the same and is going to get a spotlight shine on it at about the time when they start practicing as engineers. And we need to help them understand that the numbers 42, 13, and 16 on this graph, the dark coloured bits, are basically the structure, the substructure, and the related construction emissions. 2/3 of that embodied carbon is in the structure. We need to help these students understand how big this problem is and that this is their responsibility if they're going to enter into the workplace as a designer of the built environment. And I think this is a huge opportunity. And I think this will go down pretty well when you tell the students that this is what they're going to have the responsibility for. Because young people today have been brought up being told that they can make a difference. They have role models who've been changing political views on free school meals and on menstrual products for school children, who have been speaking out for female education rights, and who have been telling politicians things that other adults have been afraid to say. So assuming they pass, you're about to unleash a generation of designers who believe that they can change the world and do something really meaningful with their career. But if they're misdirected, they will focus on the wrong things. They will think that holidaying in the UK is worth doing for the sake of the planet. They might switch to a vegan diet for the sake of the planet and probably for the sake of their bank balance. And they may never buy a car for the sake of the planet. But how many of your students are going to graduate knowing that a boring warehouse structure like this has 5,000 tons of carbon in it? And how many of them will make the connection that if they could reduce that steel tonnage by 20%, they will have saved 1,000 tons of carbon, as opposed to 1 ton of carbon, which is the sort of things they can do away from this career that they've chosen. That 1,000 tons, by the way, that's exactly the sort of challenge I'd like to give to a graduate. That's the sort of work that we ask a graduate to do when they come into the workplace. You know, they do the final calculations on the steel frame, and by the time you get to issuing your construction documents, you should be able to say, right, let's shave another 10% out of this or more. So your students are going to enter the workplace with this scale of responsibility on their shoulders if you teach them about this. And they need to believe that this is their responsibility, whether they're asked to find that 1,000 tons or not. I think it then gets a bit tricky because it's clearly about more than just 1,000 tons. This is about the fact that we need the public and therefore politicians to demand something really quite different, which is uncomfortable. This is not about a 10% reduction in carbon from engineer-only impacts. This is about more than that. This is about influence. This is away from just sitting in a sort of technical capacity and doing some sharper calculations. And this feeds into what Hanif said earlier. We need to make our voices heard as an industry, which is obviously easier for me to ask you to do than for me to actually do myself. But I'm asking you to create engineers that are ready to have that difficult conversation with their client or their boss or the local authority about whether or not that building even needs to be constructed in the first place. So that's my opinions on that side of things. What can we do to help? What can I do to help you? So the ISRT set up the Climate Emergency Task Group in response to the declaration that happened last year. We're quite a small task group, there's just a few of us, and we report directly into the leadership. But what we're trying to do is coordinate some form of emergency response within the institution and beyond. We've been pretty busy. We've got this pyramid diagram that, but if I go from the bottom up on this pyramid, we've been resetting standards, trying to redefine what it means to be a chartered structural engineer. We're publishing guidance to help our engineers meet those standards, all of which is available online. And we're holding conferences to raise standards. So in 2 weeks' time, there's going to be a Climate Emergency Sustainable Design Conference. You can get to it through that web link on the page. It's completely free. It's free for non-members as well, so you can invite all of your students, and they can even invite their friends who are studying architecture. They can all come along for less than a half a day of free free sustainable design guidance from people who really know about these subjects. And then at the top of this pyramid, as a task group, we're trying to collaborate with as many other task groups and parties out there, because at the end of the day, this requires us to all do a bit of joined up thinking and have a common mission. Hopefully you can now see a sneak preview of the website on your screen. Do send your students here. It's full of free stuff for them. There's guidance there on circular economy. There's articles discussing, like I say, their responsibility. There's articles that talk about how to measure embodied carbon. what lean design might even mean. What are the first 10 ways to tackle making your design that bit leaner? If you've got to sit in a room and try and carve some carbon out of it, there's loads of stuff on there. Everything that we published recently is free for anyone who goes on there. And I think, as a bit of a mini library that any of your students can access, it's a pretty neat way to get hold of some of this information. A particular mention is the How to Calculate Embodied Carbon guide that's on that, that we published last month. And this was written by John Orr of Cambridge University and Orlando Gibbons of Arup with a huge review panel. And this is the first time that this institution tried to set down exactly how we count carbon in our structures, in the hope that we can all agree on the carbon impact of a certain design or a certain structure. And then finally, I want to show you this. This is a sort of sneak preview of a paper that, again, will be free on the website that we're going to publish in a couple of weeks' time, around our proposals as a task group to start using a rating system that's a consistent rating system that can be used for all structures across the world. Because I guarantee that if you start giving your students a sticker like this and asking them to measure their carbon impact and then stick this on their final year design poster like that one I showed you at the start, they will want to hit that green and that yellow tab on here because they're all ambitious and they went to university to do well. And I think that then when they hit the reality of the office and they discover that we're designing F-rated and G-rated tower blocks, hopefully that will cause them to speak up and tell us how appalling that is and how they did better in their final year project. And that will give them their little Greta moment, and hopefully then they can start to change the world. Thank you.
First of all, thank you very much for inviting me to be a part of this important event today. The challenges that we face in regards to climate change, ecosystems depletion, natural disasters, and population growth and rapid urbanization, as well as also now with the added layer of COVID pandemic, has been demanding a realignment of our focus and priorities as built environment professionals. And this reality has also in turn been demanding a re-evaluation of our knowledge and skills, which are the underlying factors of competence. A competence very much needed to deliver on the challenges we're currently facing and will continue to do so in the future. And I think at the heart of all of these challenges lies an almost perplexed dichotomy of time and scale. The scale of positive impact we need to deliver and the rather limited 10-year time frame we have been given by the climate change experts by 2030, and some of you would even argue that we're already too late to truly mitigate adverse impacts of climate change on our planet. And this begs the question of, do we have enough capacity to address the challenges? Capacity in terms of effective knowledge and skills that are needed to continuously and consistently deliver on the critical challenges of time and scale I have previously mentioned. I think it's also important to acknowledge that when we look at the big picture, we immediately can understand that in this era of rapid changes with complex and multi-layered challenges, which sometimes require us to address even competing priorities, we know that we need multifaceted and also holistic responses that are delivered fast and at scale. And in this picture, a single entity of any kind, be it an institute, whether professional or academic, a membership organization, a private firm, or even a single government, is simply not going to be enough to make a difference, to make that leap and achieve transformative change, lifting the entire industry up so that our sector globally can accelerate the transition to a resilient and sustainable future, especially now, hopefully in the recovery phase of the COVID-19 pandemic. So I ask all of us now, how do we deliver on the mission of the United Nations 2030 Sustainable Development Goals? Or if we want to be even more focused and specific on the ambition of a net zero carbon future with the work we deliver within the buildings and construction sector. And I'm speaking more as a practitioner today. But the question I ask is because I fear that the level of knowledge across the sector around the world is not uniform and or consistent. And when knowledge is also treated as a one-off and unilateral information transfer, rather than as a consistent and continuous flow of knowledge that is built on a common set of fundamentals. And my immediate response would be that that consistency is of essence, and that collaboration is a must, not only for the success of our industry, but also for a thriving future for us all. With that belief in mind, I would even continue to say that the know-hows must continuously shape and inform the basis of knowledge delivered, whether in academia or in practice, and that this knowledge must be nurtured over time, nurtured with insights gained from the collective experience of applying that knowledge in practice. So this is a mission that is currently falling behind, and especially in the formulation of today's academic curricula, within the architecture, design, engineering, and or planning programs in schools that are preparing the next generation of built environment professionals. And this is exactly what we have embarked on as a mission in a new initiative across the industry, what we call a climate framework, where we're aiming to cross-pollinate experience and expertise and create a shared curriculum framework for climate knowledge. And in this new initiative, which involves a group of representatives from the most prominent professional institutes, membership organizations, and even grassroots groups, including the RIBA, ACAN, Architects Declare, CIPSI, CIIT, UKGBC, among others, we're creating a framework, building a holistic knowledge around climate as it relates to the built environment. And we're doing this by drawing on the existing resources in order to consistently upskill the industry as well as academia. And in this united and very much concentrated and coordinated action across the industry, our aim is to break down silos and also establish a common ground, defining a common language, and identifying the fundamentals of holistic knowledge and skills every built environment professional must equip him or herself with in order to deliver truly sustainable built environments today and also in the future. And we acknowledge that the success of this initiative very much relies on the wide and unanimous adoption of its output, namely its structure. And the success of it also very much relies on its direct link to academia, where the fundamentals of knowledge are primarily delivered. And over the last few months since the launch of this initiative, we have been consulting representatives from various academic institutions and incorporating their input in the development of the proposed framework, which I will shortly present. And all in all, we so far have had input and feedback from over 150 individuals, both in industry and academia. In this manner, we're also able to address the concern around inconsistency that I mentioned before in terms of knowledge delivery and expectation, both in schools and in the industry. With Climate Framework, we aim to align expectations and create a golden thread weave through from academia to industry in order to ensure continuity and consistency in the way knowledge is built, disseminated, and built upon throughout different stages of a built environment professional's life cycle. And we also believe that this presents an opportunity to strengthen the relationships between academia and industry, and more importantly, close feedback loops that will bring in the know-hows of practice into the next generation of built environment professionals' core education. Underpinned by the vision and the mission of the United Nations 2030 Sustainable Development Goals, focusing on the goals that can be directly impacted by the work we deliver within the built environment sector, the climate framework is organized around 7 overarching themes, which are presented here, as well as a series of common threads that are shared by all. And although the overall structure of the framework is very much under development, our vision for the climate framework is that all the varying institutes and institutions, both academic and professional, as well as membership organizations would adopt this framework to build customized and appropriately detailed content on or course work on according to their schools and or members' needs and also area of focus and expertise. And this is exactly what we, as I'm also a representative of the RIB's Expert Advisory Group for Sustainable Futures here today, have done at the RIB over the recent months, setting a precedent hopefully for the other institutions and organizations to follow. The RIBA's new initiative, The Way Ahead, has been the catalyst for this change. And the way ahead signals a change with the RIBA's commitment to standards of education practice that place ethical and societal challenges and the climate and biodiversity emergency at the heart. And with a new RIBA education and professional development framework included in it, this new initiative presents a single standard covering pre- and post-registration education and professional development. And it also highlights that climate literacy, as well as sustainable architecture, form the expectations of the architects of today and in the future. And over the last few months, we have been working diligently to help shape the detailed sustainable architecture framework for the RIBA, and which actually specifically relates to the recently published RIBA's plan of work, and also builds on the RIBA's Sustainable Futures Outcomes Guide to demonstrate how the individuals can help meet the RIBA's 2030 climate challenge targets. And following this climate framework structure as the basis, the sustainable architecture curriculum of the RIBA has an adapted structure to suit the specific needs of the RIBA members who are predominantly architecture practitioners. And in this manner, there is a seamless translation of the climate framework structure to the RIBA's sustainable architecture core curriculum and learning modules. And our long-term vision is that this initiative and effort can create a ripple effect across the industry and academia. But as immediate next steps, we're starting to develop a series of recorded learning CPD modules, both for practitioners, but also arranging joint working groups with universities in the UK, at least, to create course content and also to upskill the tutors. And we would very much be looking forward to initiating a dialogue with all of you who are a part of this conference today and collaborate on this very much needed set of actions moving forward. Thank you.
Well, hello, everybody. I'm really thrilled to be here, and I want to talk to you about a story about the future of where I'd like to get to and where I was in the past, and recognition of the necessity of change and change over time. And so the future that where I'd like us to be is a future where I can tell my grandchildren that we came together and solved a great climate crisis. And the past of where we were, where I was taught engineering and architecture in a really modernist way in which I thought that most of the answers were solved. So what I've learned over the last 30 years of practice is that my impact on the world is greater in my professional world, as Will talked, than it is in my private life, and that the opportunities to change the world are critical, that we come together and collectively share information and act together. So I see that we're really at a tipping point, and that tipping point of where we get to a carbon positive future, it takes people coming together and sharing information and being flexible and willing to adapt. So I'm really inspired by the opportunity of this collaboration, and see that this decade is the critical decade to act. If we think about it from an education perspective, we are training the future of the engineers and architects that will be this moving tide to create this regenerative planet with healthy people, healthy buildings, a thriving economy that we can move forward. So I'm here to share information from North America. I head up the Carbon Leadership Forum. This is a group that has support from building owners, manufacturers, builders, architects, engineers that are all collaborating around reducing the material impacts of construction. So we're particularly focused on the embodied carbon, the emissions that take place from manufacturing and transporting and constructing buildings, but integrating that into a total carbon reduction scenario. And as Will brought up, we can look and see that the impact of the built environment is massive, and that the need to transform buildings to be net operational energy zero for all new buildings pretty much today, existing buildings in the next decades, and then figuring out how to decarbonize the industrial manufacturing processes that make cement, steel, glass, carpet, furniture. So when we look and see the impact of buildings on the climate crisis, we can see that we have a significant ethical responsibility. Yet the challenge is that most of the educators within the building sector were trained, 20 to 30 years ago. So as educators, we we were taught really a deterministic view of the world, and yet we're faced with a challenge of change and industry transformation that's faster than many of us can even imagine possible. So, and so what when we look at decarbonization, here's a plot from California. So we can have a regional strategy of decarbonization in which California has identified that they are continually growing population and their GDP, but they're seeing declines in greenhouse gas emissions where they get down to a target of how they get to zero by 2040. But when we look at the emissions that are taking place within a region, we're not necessarily addressing the carbon loophole or the emissions from purchased goods and emissions. And for buildings, those are the building materials that we build with. And so if we look to drive decarbonization of these building material production, we need to make sure that we do this in a globally aligned way so that we don't just outsource emissions to somewhere else in the world. So if we're looking at strategies of reducing the carbon impacts of buildings, there are a range of different strategies from optimizing the project and deciding not to build a building to begin with, optimizing a system, say choosing a wood system versus a steel or an alternate framing method. And then thirdly, there's ways of optimizing procurement, so specifying purchasing the lower carbon options among equal things like the lower carbon concrete or the lower carbon cement. And all of these strategies should be looked at and approached. In addition, we can really think about reconceptualizing the system of manufacturing and to building materials. So right now, building materials are manufactured, emissions happen when fuels are burnt to heat things up, and also when chemistry takes place and carbon goes and other greenhouse gases go into the atmosphere. If we think about carbon as a material resource, we capture carbon and we turn it into a material flow, either from biogenic materials or in high-tech materials. We can think about that buildings, which consume the largest volume and mass of materials globally, buildings and infrastructure, they have the potential to be this market pull for decarbonizing the industrial sector and for eventually storing more carbon in long-life building materials than are emitted when making them. So I think, so at the Carbon Leadership Forum, we have adopted a collective impact model. So we are collaborating with industry, academia, and government to advance research, resources, convene a network, and incubate member-led initiatives. And I just wanted to share some examples of that. The Embodied Carbon Construction Calculator is a tool that collects embodied carbon reporting and environmental product declarations from building material manufacturers and pulls them all together in a way that enables people to identify lower carbon options. That is a free and accessible database at buildingtransparency.org that was conceived of by a general contractor, brought together with over 50 industry partners to advance this open access database. The Structural Engineers 2050 Challenge, so similar to Structural Engineers Declare, the Carbon Leadership Forum issued a challenge to structural engineers that they should commit to track and reduce embodied carbon to zero by 2050. The American Society of Civil Engineers got together and is creating an initiative that is about a commit of how to track and report that. So what are the actions to demonstrate commitments to that? So a shared alignment on what our long-term goals are, and then how do we track and reduce them. We've convened a network that was primarily focused on embodied carbon that's growing globally. So we've got 289 members in the United Kingdom. We have an online community platform where people ask questions and share resources, as well as an academic focus group. And so we're looking for more people to help engage in this network in terms of sharing knowledge and resources on this emerging topic. There's additional policies that are coming around in cities, states, and federal governments exploring how to integrate embodied carbon into practice. And if I think about the changes that are needed at the from an academic position in my role as department chair in the Department of Architecture, is that we need to make sure that we are ensuring that our students are able to collaborate, be flexible, adapt, and move forward. So in some ways, we may think of engineering as a fixed discipline or thing, there's knowledge that we need to make sure that students have. I think the one thing that we know is that we don't know what is going to happen in the next 10 to 20 to 30 years. And so more important is making sure our students leave with optimism, ability to adapt and innovate and collaborate. I want to end with a quote from this book, The Future We Choose, by the authors are named the architects of the 2015 Paris Agreement. It says here, "This is the decade in which, contrary to everything humanity has experienced before, we have everything in our power. We have the capital, the technology, the policies, and we have the scientific knowledge that we have to halve our emissions by 2030. But only if we choose this decade. Our parents did not have this choice because they didn't have the capital, technologies, and understanding. And for our children, it will be too late. So this is the decade, and we are the generation." Thank you. I'd like to leave us all with that challenge.
So that brings us to the end of session 3. And we now move on to the Q&A session so any questions for Will, Mina, and Kate, and I will put those questions to them. We have had a few come in, so I will start with a question from Andrew, which was addressed to Will. That's Andrew Phillips. And Andrew asks, he said he recognizes the student and it will have industry input into it. How do we get the bold information that you've presented to academics and then to students? And then how do we persuade students and industry collaborators that saying that shouldn't be built is an option? Perhaps we need companies to present examples of projects that they didn't do rather than projects that they did. Any comment, Will?
Yeah, what a question. Thank you, Andrew. You sort of answered it in part. I think at the end you sort of suggested that maybe we need to be presenting better examples of what we've done or what we haven't done. And I agree with that entirely. I think the first step is to at least be acknowledging so I've tutored at quite a few different university degree courses over the last sort of 8 years or so. And I've not really ever had the opportunity to agree with a student that they maybe should be questioning parts of the brief because all they ever present is we want to build this and we want to build this. And I don't know how many engineers who would go into tutor or lecture would feel comfortable in saying to the student, have you questioned even not doing it? So I think there's obviously there's a mindset change first. And then I agree that we need to be better at sharing examples of people asking the big questions. There's the big questions and the small questions, aren't there? And they're both important. Clearly it's still important for engineers to be asking the smaller questions. Do you need that 24-meter span link bridge, or could you live with a column in the middle of it? I think we can make this work. This will be simpler, blah, blah, blah. But to get to the point of being able to confidently ask those maybe smaller questions, you do need to be better practiced in it, and that practice is best done at university because you can make mistakes and you can ask the wrong questions, and that's all okay. So clearly we need to encourage asking those small questions, and I think part of the inspiration for the small question asking comes from the big question asking. And I mean, the best example I've been taught to date was by a civil engineer actually, who is a guy in Arup, and he was asked by one of the major airports if they would bid to design an extra car park or extend one of the existing car parks. And instead of just saying yes, he went back to the client with the question, why? Why do you need more car park? And the client said, well, we don't have enough car parking spaces. So he went to the client again and said, well, why do you not have enough spaces? And they shared data that showed same time every day the car park's full. And when we looked into this with them, it all became pretty clear pretty quickly that it was full the same time every day for a fairly short period of time, and then it was fine the rest of the time. And without wanting to make reference to COVID, there was just a bit of sort of flattening the curve needed, and we worked with the airport to look at maybe how would it be possible to rearrange the flight times, bring people in a different pace through the day. They did that. We didn't build them a car park, and that's the best example I've been told so far of this sort of really helping the client get more value than they could have expected out of the brief by just not giving them what they asked for. And I agree with you, Andrew. We need to share stuff like that with students. We need to give them then the confidence that people are asking this stuff and clients do respond well to it.
Okay, very good. Thank you. A very tricky situation, I guess, to try and balance everything that we need to do, but at least having the conversation is a step forward. Stephen Garrity asks a question from Mina. He says, it's very interesting to hear of REBA's The Way Ahead, but it is the ARB that has the largest impact on the undergraduate curriculum in architecture in the UK. Do you know if the ARB plans to adopt the REBA's new education and PD framework?
Thank you for the kind question. I think it's important to note that we also have been working very closely with the ARB as the RIBA Expert Advisory Group for Sustainable Futures over the last few months, more so actually before the lockdown, to enable some sort of a seamless integration of this framework into the ARB criteria as well. And there was, and I'm not sure how much of that I could officially share, but there has been work that has been done in the background, although ARB for the time being, I understand, has taken the decision not to implement it immediately today. And our hope was that it actually could be implemented as soon as this year. But I understand there is a bigger reformulation of the ARB criteria with various validation criteria and topics to consider in addition to climate change, and therefore that will unfortunately need to take a bit more time for ARB to adopt. But there is definitely that link that we've been trying to create both within the ARB and the RIBA with this work that we are very excited about, that we feel it's important to implement.
Thank you.
Thank you
for that, Mina. Another question came in for you. So Fiona Gleed asked an interesting question or comment really. She said, much of the discussion today has focused on educating built environment professionals. What should we prioritize if we are teaching in engineering departments where building design is a specialism within civil engineering and pushed towards later years? And this is a question that was prompted by Mina's mention of the built environment professionals, but something that she's been thinking about throughout the afternoon. So I don't know, Mina, if you have any further comments on that or thoughts.
I can sort of share it. Thank you so much for this very interesting question, and I find it actually a bit challenging to respond because there isn't a direct answer. But I would like to shed some of my observations at least, as we've been working and trying to bring together. I think the fundamental part of this, you're completely right in noting that there has been so many consultancies and specialisms that have evolved and developed over the years. I would even imagine there will be a climate change consultancy that will soon emerge in the industry. And I say that both in a positive way, but also in a negative way. In a positive way because we need that level of detail and depth of understanding and expertise to be able to really drive this transition as fast as possible. But that shouldn't neglect the mainstream industry to be uplifted in parallel or collectively or together. And for that reason, I think it's really important to have the specialists and expertise, and engineers are at the pinnacle of the specialism when we talk about climate change and sustainability and so forth. I think it's important to educate them as specialists and experts in the subject matter, but it's also equally important to perhaps embed them into other disciplines, into perhaps the courses of architects, for example, so that there is that diversity and collaboration integration that happens from day one in architecture schools, because we see this very much replicated in the industry as well today, because the specialists alone cannot drive that change, or architects, and I'm just an architect, and that's the reason I'm giving that example, but architects, planners, they also cannot drive that transition and transformation. So everyone needs to come together, and I think perhaps diluting the boundaries or breaking the silos and working collectively together would be essential, I think, moving forward. In addition to having the specialties, for that reason, we should also have the mainstream knowledge implemented across the industry and academia. Hopefully that answers a bit of your question.
Yes, thank you very much.
To that?
Yes, please do. Go for it.
Well, because I think, we think about the fundamental principles of engineering, about, designing and building and enabling infrastructure, clean water, good roads, bridges, buildings. All of these things, we talk just under civil engineering, but we could include all of the engineering, is about designing towards, this desired future state. And if we focus on the values that are important and the goal of what we're looking to accomplish, all engineering has an aspect that connects to the future place where there is clean water for all and a healthy economy and resilient buildings. And so if we think about the shared values and how climate comes into play there, then there are places in which climate action fits in all aspects of the discipline. And a lot of the things that, even roads and drainage culverts fit into climate solutions. So it's not just buildings, even though we were talking about buildings here.